What's up, guys? My name is Michael Lin. Welcome to my YouTube channel. Today, sorry guys, for a while I haven't been live streaming at all. I haven't been uploading at all lately, mainly because some issues of I'm having issues with school and stuff like that, and studying for tests and all this other nonsense and doing research. So all this stuff is happening to me. So now I couldn't really live stream that much, but now I'm back at it again, live streaming. We were doing the other day. We were doing AtCoder 154, right? 154 contest, and we had trouble with that. AtCoder 154. I think I just go back to. Let's go back down here. Okay, so we were having trouble with that. So what I did in order to actually try to get onto the what was it? What was the problem? I think it was D, dice in line. I think. Oh no, it wasn't D. It was I think it was E. It was E. Yeah, it was E. Okay. So what I did, I actually posted this question on Code Forces to see if people can help me with it, and surprisingly, a certain number of people actually did. So for there's a guy who actually answered my question to actually how to do this. There's two ways you could do it. You could actually first brute force everything, so you don't actually have to use dynamic programming for this problem. And the other guy who answered me for dynamic programming, I still didn't really understand that much about what he was talking about. But apparently you can use dynamic programming to solve this problem. But so let me just go to quickly to the settings of the blog that I posted, this one right here, and show you guys what I mean by it. So you could actually brute force everything. So let's just go to here and show you guys what I mean. So what you could do is, first of all, you could actually go through every single part of the input string, and then let's do that real quick. Let's actually do that. So first of all, I'm going to do basically the same thing as what this guy did, and I'll show you how to actually do it. So let's go to Visual Studio. So let's go back to the problem real quick. Let me see. Is anyone in the chat? It's okay. I haven't been live streaming at all lately, so it's okay if no one's in the chat or no one's watching at all. But it's okay. It is what it is. But anyway, let's see. So remember, we have to find the number of integers between 1 and n that contains exactly k non-zero digits written in base 10. So what we could do is, I think this was another contest I did. I don't remember. I don't remember this problem. Okay, let's take this back. We still need this t minus tt. Okay, so let's see. Okay, so read in n, read in t, and then we have to read in. Oh no, we don't have to read in t. We have to read n and k. My fault. Okay, so let's read in n and then read in k. So we're gonna do that. Read in n and then read in k. Okay, so here let's call this k and n. So we're going to read in n and read in k. So remember, n is the number that we're trying to get up to, and then k is the number of non-zero digits that we have to write a find for that have k non-zero digits in order written in base 10. Okay, so what did the guy do? Okay, so let's go start here. First, when we read in n and read in k, remember it has to be a string, by the way. These both actually have to be a string. So n should be, let's see, n. I think k is let's see. Did he use k as a? Oh yeah, k. So k is an int, and then n is actually k is an int, n is a string actually. So we have to do that. So let's do that real quick. So okay, and then k is n is a string. K is a number that we have to find a non-zero. Okay, so now what did he do? So let's go back to here. So let's start out with the first part. So first, let's read. Let's find the size of the actual string. Right. We're gonna create we are going to create an array of characters. Right, for characters, and each of them are. So we read in the string as a string of numbers, right? Now what we're going to do is we're actually going to create convert it into an array of regular numbers, actual integers, right? Because we originally read it as a string of characters. Now we're going to read it in as a separate array of numbers. So let's do that real quick. So let's do this. So what I'm going to do is I'm going to do this called let's call n. Let's call this equal to, let's create a variable called length, and it's going to equal to the size of n. Okay. The size of n is just the, wait, hold up. We could actually do n dot size. I think that's the right one. So that's going to be the length of the string that we inputted, right? So we inputted the value of n, and we're just which is just the string of the numbers, the last value that we have to get up to. And now we're just creating the length of our array that we're converting it into an array of numbers. Okay, so that's what this is for. Right? That's just the length of the array of numbers that we're going to convert it. So now let's actually create our vector of array of numbers. So let's call it digits. Okay, and this is going to hold up. Yeah, so this is going to be the same length of length. And now we're just going to convert. We're going to loop through this and just convert our string into its equivalent digit form. So that's what we're going to do. And I'll tell you guys why we're doing this. Length I plus plus. Okay, and then digits at I is going to equal to the equivalent of its digit form. So it's going to be string at the string, which is n, what we read in n at I, minus 0, right? So what am I doing here? So we write in the string n. The string n is the, if you guys knew about the question here, if you're just joining the chat, or if actually there's no one in the chat, but if you're just joining here, the string n is the number of digits we're going between, right? So n is the final endpoint, the final range that we're got to go up to, right? And we need to find exactly k non-zero digits, the number of digits between 1 to n that contain k, exactly k non-zero digits, written in base 10, right? So what we are doing right now is we're going to read in n, which is the last range of our string, as a string, right? We're going to read in the n as a string, and then we're going to convert the string into its equivalent digits. That's what we're doing. Okay, so that's what we're doing here. So right here, this converts it to its equivalent digits. Okay, so now let's go back to what he did. Now what we're going to do, I think he used a suffix sum. I believe so. So I'm not so sure what he's doing. So I think he used, okay, yeah, so, no, he used a prefix sum. He used the prefix sum. Okay, so we're going to create a prefix sum. This is just to see, we might use this later. I don't know if, okay, wait, let's see. I'm not sure if he actually, wait, if he didn't use it, then I don't think there's a purpose to it. Wait, let me see. He might actually never used it. If he never used it, then I don't even know what's the reason that we did this. Sorry, guys, I just read his solution as well. Okay, so he actually never used his prefix sum. Okay, my bad, guys. Completely disregard everything what I said right here. We don't actually need to do this. Okay, we don't actually need to do this. We don't have to convert it to its equivalent form. I'm going to comment it out in case we actually do need to do it later on. But I don't think we have to, based on his representation. Yeah, I don't think we actually have to. Okay, so let's start with this. We're going to brute force everything. Okay, so let's create a value called answer, and then we're going to set it to 0. So this is going to be the number of answers that we're going to do, right? The number of values that we're having, the number of end result of number of digits that actually contain k non-zero digits written in base 10. So that's what this k equal 1, that's what answer is supposed to be for. Okay. All right, so now what we're going to do. Okay, so if we check, let's look at the cases. So the cases we could have is that we could have k equals equal to 1, 2, or 3. So for each case, we're going to have to do something. Okay, so let's look at this. So if k is equal to 1, so that's the first case. Let's do that. So if k is equal to 1, that's the first case. So that's like, we're going to set answer to equal to size of n, which size of n is just n dot size, and then we're going to do -1 and then multiply by 9, and then we're going to add it to the first value of string n. Oh, okay. To the first equivalent value of n. Okay, so let's do that. That's n at 0. So then convert this to number form. So what does this do? Okay, so if k is equal to 1, that means that we need to find the number of digits between 1 and n that contains exactly one non-zero digit written in base 10. So it contains one non-zero digit, right? So if the length, so if I want to find the number of digits between 1 to n that contain exactly one non-zero digit, let's go look at this. 101, right? Let's look at 100, this first case of n is equal to 100, k is equal to 1. So I need to find the number of non-zero digits that contain, I need to find the number of digits between 1 to 100 that contain one non-zero digit written in base 10. So this one, from number of digits from 1 to 100 that contain one non-zero digit written in base 10. So that's what this 19 is, and these are the values that contain one non-zero digit written from 1 to 100 in base 10. So how did they get 19 here? Well, if you look at this, we're going to take the size of the number of digits that we have. So the number of digits we have is 3. So we have 3 digits, 1, 2, 3, right? So like this, because it's the size of the last value, the size for each digit, right? So we have 3 of them, because as we're going from 1 to 100, the size is 3, right? So we're going to take the size of n, and then what are we going to do? We are going to multiply it, subtract it by 1, and then we're going to multiply it by 9. Now, why do we do this? Okay, so if we subtract the value by 1, we're excluding the first digit, right? We're excluding the first value. So that's these two places. So we have the tens place and the ones place and the tens place, right? And how many non-zero digits can you have for that? Well, the number of non-zero digits is just 1 to 9, right? So then that's why we have 9 for each of these. So we have 9 for each of these. So this is 1. First place, we're going to have 9. Second place, we're going to have 9 also. Okay? So that's the reason why we have 9 for each of these. So if we're going to count how many digits for each of these, it's going to be the total size, which is 1, 2, 3, right? Let's get rid of the first place, right? The first placeholder. And then so that'll be 2. So the rest of these, that's the number of places that we need is 2, right? We're going to take 2 and multiply by 9, right? Because that means that each of these places have the corresponding value of 9. There's 9 digits that you could put for each of these places, the ones place and the tens place, right? So that's why we have 9 for each of these. So then it will be 2 times 9, right? A number of places would be 2 times 9, which will give us 18. So that's what this is for, right? Multiplying it by 9. Okay, so now what we're going to do is we're actually going to take the current digit at the first place, and then we're going to convert it to its equivalent value. So this time it'll be 1, and then we're going to add it, right? We're going to add this value to the current number, right? So whatever is at the first place, we're going to add it. And why do we do this? The reason why we do this is because we know that the first digit for any value that we input, so like 1, 2, 3, 4, 5, right? Whatever value, this digit cannot be 0, right? Because if it wouldn't make any sense, because when you input values for n, let's say you're inputting 90, right? You're not going to put 0, 90, right? You're just going to put 90. So we know that the first leftmost place of 100 is going to be a non-zero number, right? So this leftmost place number, we could just convert that into its equivalent value, and then just add it with the rest of these places. Add it with 9 times the number of places that we need for the rest of them. So that's why we do this, okay? So that's why if k is equal to 1, we're going to take this. I don't know why we're getting a weird answer. Maybe it's because of, so they're saying I might have overflow. If that's the case, then we could, I don't know if, I think I could just cast this and dot size. Wait, oh yeah, wait, hold up. I could just do this. So I'm gonna take length and I'll change this to, whoops. I'm just gonna call in the variable length. So then it casts it. So then I won't have this issue. Yeah. So it casts this into an integer. Okay. So that's the first value of k is equal to 1. So now let's look at the second value of k. Hold up. How many people? Okay. So yeah. So in the second value of the second placeholder that we could have, or the second, not placeholder, the second scenario we could have is when k is equal to 2, right? Because like if we look at number of k's, we have 1, 2, and 3. It's k is between 1 to 3. So we have a second place of k could equal 2, which is second scenario. Okay, so if k is equal to 2, let's actually set our answer back to 0. So just in case. So if k is equal to 2, let's set our answer back to 0. So answer is going to set back to 0. Just in case if there's like any garbage value, we could do that. Okay, so now what are we going to do? We're going to go through each place of the values for each place, right? So for k is equal to 2, we're going to go through every single place. So for this one, we're going to start out with 0 up to the size of n, and then j is going to go from I plus 1 to the size of n, and then we're going to go, this is going to calculate the number of digits that are not bad, okay? So that's what we're going to do. Okay, so we're going to go from the beginning and then to the end and then calculate the ones that are not bad. So let's do that. So we're going to start from, for int I is equal to 0, I is less than length, I plus plus. And then this one is going to start the one after, like the next, the place after this, right? So j is going to be equal to I plus 1, j is less than length, and j plus plus. Okay, so that's this part. That's this part of the whole part of this. Okay, hold up, let me check something real quick. Let's check the live stream. Are there anyone here? Okay, so what's up guys? There's 2 concurrent viewers. How are you guys doing? Okay, all right, so now if you're new here, I'm just going over this next value. Okay, so now let's go through here. We're gonna check if these values are bad. So let's actually go. We're gonna go through and do a create a function for bad and pass in these values. Okay, so the first 2 for loops is just gonna go through every single place in the 1's place, 10's place, 100's place of the string n. So like in this case, if I have n is 100, right, it's gonna go through from 1 and this part and just keep going, check to the right side, right side, up to n, and then this is gonna loop from here to the end value, right? And this is gonna loop from here to the end value, and then we're gonna go from here and go to the end, and then you go here to the end. Okay, so that's what the first these for loops are going. Now what we're gonna do is we're gonna have a check every single digit from 1 to 9. Okay, and the reason why we're doing this is because we need to check every single digit from 1 to 9. So because that's the only non-zero digits, right? So let's do that. 1 and then d2 is less than or equal to 9, d2 plus plus. Because these are the only possible digits that are not possible, right? That are non-zero. That are not zero. These from 1 to 9, and then d2 is going to go from 1 to 9, and these are the only possible non-zero digits, right? Because our problem is we're checking every single non-zero digit from that contains exactly k non-zero digits from 1 to n. So that's why we need to check all the ones that are non-zero. Okay, and then what we're going to do is we're going to do answer plus equal to bad. And this bad function is we're just going to pass in I, j, and then d1, d2. Okay, I'm going to see if I could do a DP solution of this problem next. If I can't do it. If I can, I'll try to do it if I understand the tutorial, but I'm not so sure if I actually 100% do. But so that's what we're going to do this brute force solution, okay? So now we need to create our function bad. So that's what we're doing here. So we're going to have this function bad, and it's just going to take ij every single place of ij, and then the corresponding digits that we could have. So d1 and then d2. Okay. Okay. So let's go back to what he did here. So if it's not bad, then we're going to just add the answer to it. Okay. So that's what we need to do that here. So if it's not bad, we're gonna add the answer. After this, we're going to just print it out. So right here is cout answer and null. Okay. So that's what we do here. That's what we're doing here. So now let's go to our function bad and see what he's doing here. So in function bad, we need to check if so if the first place we have is equal to 0, we have to check if it's equal to 0. Okay, so we need to do that. So we're gonna first check if return if I is equal to 0. The reason why we're checking if I is equal to 0 is because if your first place is not equal to 0, then it's so if your first place is not equal to 0, like if the first place is not equal to 0, then that means that it's good, right? If the first number that we're checking is not equal to 0, it means it's good. All right, so that's why this is just checking if the string that we input is bad. Okay, so we need to have the first place equal to 0, so that means it's bad. Here we need to check if the digit that we're looking at is greater than the current digit. Okay, yeah. So in the function here, we're going through every single possible digit that is possible from 1 to 9, right? D1 is going to go through every single possible digit from 1 to 9. D2 is going to go through every single possible digit from non-zero digit from 1 to 9, right? Because these two are non-zero. So now we're going to input those two in I and j. Check if the corresponding digit at I, which is the place that we're at, and D1, the place that we're at is D1 is at D1 if it's greater than the corresponding actual digit at the ones place, whatever place it is for I, right? That's what this is for. And then we need to do this part. Okay, so so we're gonna do that. So here, if equal to 0 and D1 is greater than n at I. So I didn't actually have a value to convert it to, so let's actually create a string here and then convert each number to its corresponding one later. So now it would work. Okay, so now here I need to convert this to its corresponding digit. Okay, so I might actually convert it for all of these. So let's see. Corresponding digit of I is going to equal n at I minus 0. So this gets the corresponding digit. This converts whatever place that we're at to its corresponding digit, like what the actual value. So like if I'm at like the hundredth place, it will convert it. Let's say I have 100 and I'm at the 100th place, like in here, this 100, and I'm at this place, 1, it's going to convert the current place into its equivalent value of 1, right? Because I inputted the value as a string. That's what I'm doing here. Okay, so now I don't need this. So this is going to be corresponding digit of I. I'm using large variable names here for the sake of readability. All right. Oh, hey, how you doing, sir? How you doing, sir? If you're new here, I'm just doing the live stream, solving the last problem of solving the last two problems of AtCoder contest 154. That's what I'm doing. Okay. So that's the first part. Or if the d1 is equal to n of I. Okay. So here that's okay. So this part, if it's greater, then it's bad, right? If the second digit is greater, then that means it's bad, right? If the current digit we're at 2 is greater than its corresponding place, corresponding digit, then that means it's bad. So that's what we're doing here. Or all of the digits are 0, I think. So here, or d1 is equal to d2. So if d1 is equal to corresponding digit of I, and it's all zeros. So if d1 is equal to corresponding digit of I, that's what we're doing here. And it's all zeros. And d2 is greater than the corresponding digit of j. So let's see d and a j. Then it's bad. Okay. So let's see. We're gonna do corresponding digit of j. So that's n of j minus 0. Okay, so that's this part. Wait, I just removed something. I think it was d2 is greater than, yeah. Okay. So that's this part. Okay, so if so how do we know if what we're inputting is bad? If it has a 0, right? If it has a 0, that means we know it's bad. Right? That means it doesn't contain the actual digits, right? So like, let's say I'm inputting a value of, let's say, 25, right? 25 is the end result, the last range from inputting the values from 1 to 25, right? We need to find the number of digits between 1 to 25 that contain exactly 2 non-zero digits, right? So I'm going to input the values from 1 to 25, and it contains 2 non-zero digits, right? So if, let's say we have, how do we know if it's bad? So if we have a digit that contains a 0, then we know it's bad, right? If we have a digit that contains 0, that means we know it's bad because we were trying to find exactly the number of digits that contain the number of numbers that contain 2 non-zero digits, right? So if it contains a 0, we know it's bad, right? So that's what this is doing. So if at our corresponding place, if it's so if we're looping from here, starting from the 0 to the end, and then from here to end, if this place is a, so if hold up. So let's say d of I is 1, and then a d of 1, the first digits that we're checking is 1, and the second digit we're checking is 2, right? So the first digit, d1, is the one that we're checking, d2 is 2, right? And then we're checking if the current value at the location of I and j, so at the starting value, is passing those in is not bad. So if it's bad, we're going to return false, right? So here, if it's equal to 0, we know it's bad, right? We know it's bad because it's equal to 0, right? It contains a value of 0. Here, we're going to check if it's greater than the current equivalent value. So let's say I have like 8. So let's say over here we have 14, right? So let's say 25 and 2 So we're gonna go through from we're gonna go 1 and 14, right? No, not 1 and 14. My bad. We're going through all the values. We're gonna start at the place of this 2, and then we'll start at the place of 5, right? And then we from this index of 2 and looping to the end, and then we're starting from 5 and looping to the end, right? And we're gonna check the corresponding digits 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and check if it holds for each of the values, comparing it to the corresponding digits of 25, right? Comparing each of those for its corresponding place, right? So if we're at, let's say we're at, let's just go through it at this time. So if we're at 25, if our current digit that we're checking, right here, so let's say it's greater than, so let's say I passed like 3. Let's say we're doing 3, right? We're checking the digit 3, and it's greater than the current digit of the first place, which is 2, right? So it's probably bad. That's bad, right? Because that means that I can't count this. I cannot count a digit 3 for the number of non-zero digits between 1 to 25, right? The reason why I can't count the number of digits between 1 to 25 for digit 3 is because any number that starts with a digit 3 is greater than the first digit of 2, right? So we can't count that, right? It's not in our range from 1 to 25. So that's why we're going to return false for that. So that's why we check that here. So that's this part. D1 is greater than the corresponding digit of I, right? So if I'm passing 1, 2, 3, 4, 5, 6, 7, 8, 9 for D1, and if it's greater than the first value, we know that's bad, okay? We know it's bad. If it's greater than the first current index we're going at, we know it's bad because it's not possible. Like, it's not possible for it to be in the range of 1 to 25, right? Okay. Now, if we're going to pass in D2, D2 is going to be the second digit that we're checking from 1 to 1, 2, 3, 4, 5, 6, 7, 8, 9. We pass that into this function as well, and we need to check that for its corresponding digit. If it's greater than the corresponding digit of j, right? So for I and j are just the positions we're going to check. So I and j from here, we're looping from the start and going to the end. That will be I. J, we're looping from I plus 1, which is the next position, and going to the end, and that'll be j, right? That part will be j. Then what we're doing is we're checking every single possible digit, 1, 2, 3, 4, 5, 6, 7, 8, 9 for each place for I, and j, we're checking 1, 2, 3, 4, 5, 6, 7, 8, 9 for every possible value for j. And what we're doing is seeing if it's greater than the current digit, that means it's not in the range. So that's why we're returning bad, or returning false for that. So like if I have 6 for j, if I have 6 for j at this part, 6 is greater than 5, right? 6 is greater than 5. So that means that 26 is not going to be a possible digit that we could have that contains 2 non-zero digits, because 26 is not in the range from 1 to 25, right? The same thing as having like I check for a digit 4 or 4, right? At this position, I, starting from position 2, the index of 2. If 4 is greater than 2, right? So that means it's bad. Why? Because I don't have whatever number that starts with 4, it's like 41, 42, 43, 44, that's not in the range of the numbers between 1 to 25, right? So those don't count. That's why it's bad. So that's why we return false for that as well. So that's what we're doing here for this part. For d of I is either equal to it, that's bad. If it's d1 is greater than to it, it's probably bad. For this one, if it's equal to it, we need to check if it's all zeros, right? If it's all zeros, the rest are all zeros, it's bad, okay? It's bad because you can't have any zeros, right? We can't have any zeros in this in the value that the function we're trying to pass through. So we're trying to find the number of integers between 1 and n that contain exactly k non-zero digits when written in base 10. So we can't count we can't count a non-zero digit. Each of them can't be 0, right? So that's why we have this. So let's create a function of boolean is all 0, and it's going to pass in I and j, and we're just going to check through between those places to see if it actually contains 0. I think that's what he did. So let's go up here and check. Yeah, okay. So that just checks if it contains all zeros. Oh, so he actually did create a prefix sum. Oh, that's actually wild. Prefix r minus l minus equals 0. So he actually did use a prefix sum. That's actually wild. Okay, so you use a prefix sum to sum up the values and to sum up the values of every single digit. And then once he sums up all the values of each digit, he adds them up. And if one of them if it's equal to 0, that means all the digits are 0. So that's what he did here. Okay, let's actually do that. Let's do that. So let's go back to here. So this so here we're converting each of the digits into we're reading in the value of n, and we're converting the string into its equivalent digits. And now let's create a prefix sum for this. So let's do that. I might actually make this global. Okay, because I don't want to deal with. Okay, so I have a global variable. I'm gonna call this. I think did he do index at 1? Okay, yeah. So he indexed it at 1. I'll do the same thing as what he did. So let's do that. Prefix sum is going to equal to vector int size of n, which is length. Prefix at 0 is going to be n at 0, and we're going to convert no digits at 0. That'll be digits at 0. Prefix. So this is a prefix sum. You should know the algorithm by now because I explained it in like a lot of the videos. But yeah, now we're gonna start at 1 and go up to the length, and then add up the values. Okay. Yeah, let's do that. Prefix at I is gonna equal prefix at I minus 1 plus digits at I. Okay. Prefix. So we're using a prefix sum in order to check if all the digits are 0. So that's what we're doing here. Which is actually kind of smart. I'm not gonna lie, that is kind of smart. So yeah. So now once we have the prefix sum, let's just check it. So here, to check if the values are all the values are all 0. If j is greater than. Okay, let's make this left and right. Left, right. So this is like the range that we're checking, like from left and right. So if the left is greater than the right, all 0 is just checking if all the values are 0 between the left and the right of whatever place we're at. So if left is greater than the right, we're gonna return true because I mean, like, it's probably all 0 at this point if the left is greater than right. Otherwise, we're gonna subtract the current prefix sum. We're gonna get the right side. We're gonna get the right side, so we're gonna check. So let's get the right side, and then we're gonna subtract. If the left is equal to 0, which is at the first place, we're gonna subtract to 0. Otherwise, we subtract left minus 1. The sum of left minus 1. Okay. So this would just get you the sum of all the values between L and R. That's what it would do. So he's doing the same thing as like all K values. So that's left, right. So prefix sum of right minus. So if left is equal to 0, that means we're subtract. So he's using like it's kind of the same thing as K consecutive prefix sum, right? If you're trying to find like the sum that's like consecutive between the number of values. of k. So if left is equal to 0, we'll just return 0. No, we find the sum of the right minus 0. Otherwise, we're going to take prefix sum of the left minus 1. Okay, so we're going to take the right side of the right minus 1 minus left. Okay, that's what we're doing here. If the sum is equal to 0, if the prefix sum is equal to 0 between left and right, that means that all the digits between left and right are 0, right? Because we're adding up the number of digits, that means 0. Otherwise, it's not. Okay, so yeah, is all 0 is just checking between the boundaries from the right side and the left. So like those values between I and j, and checking if they're all 0 between. Because if it's all 0, then that means it's bad, right? That's bad. So that's what this is doing. So like this function bad. Let's say I'm going back to this problem of 25. So let's say I have like, let's say I input a value of, let's say I'm checking since I'm brute forcing all the digits and checking if it's possible, right? Let's say if I have like 30 or maybe not, let's say I have 30, right? What it would do, the bad function is what it would do is it would do a prefix sum of 30. Then it would check between the two places of 3 and 0, check if those values have, the number has a digit 0, right? Because it's going to add up 3 plus 0, it'll be 3. And if 3 is equal to 0, that means all the digits in the range of from all the values of 30 would have 0, right? Because if you sum up all the digits and they all equal to 0, then that means that all the digits are 0. So that means it's bad, right? That means it's bad. So that's why we have this function. That's what this is for, right? If it's all 0, it's bad between the ranges. Okay, so that's what this did. So what we're doing is here we're just brute forcing through every single digit and then checking if passing in for each digit, checking if it's good or bad for D1 and D2. And then, yeah, if it's not bad, then we're going to add 1. Right, add 1. Okay. If it's not bad, we'll add 1, right? So bad would just, yes. If it's not bad, we're going to add 1. Otherwise, we're just going to do what it is what it is. Now let's do the same thing for k is equal to 3, which is the final case. So what he does is that he does the same thing. We're just doing the same thing, and we pass in I, j, and k, and then we do the exact same thing. So yeah, we're going to probably copy and paste and just do the exact same thing. So we're going to brute force every single digit from here, and then just check if pass in I, j, and k for three values. So here, I, 0, j, and then here we're going to do for int k is equal to j plus 1, k is less than length, k plus plus. Here we're going to do for int d3 is equal to 1, d3 is less than or equal to n, less than or equal to 9, d3 plus plus. And then we're going to pass that into here. Answer bad plus 1, and then we're going to pass in k, and then we're going to pass in d3. So this is another function of bad, and this does the exact same thing of k is equal to 2. So let's copy this. D1, D2, and then D3. And then the difference is that we have to check a few more cases. So let's go back to what he did. So let's go up to here. So if we're going to check for different cases, hold up. The third one is the same thing, except that D2 is greater than, we need to check from k minus 1 and then k. So it's the same thing. If it's all 0 and D2 is greater than n of j, or D2 is equal to n of j, and it's all 0, and D3 is greater than n of k, then it's also bad. Okay, so so here, do the same thing. D2 is greater than corresponding digit of k. So let's do a corresponding digit of k. So corresponding digit of k equal to n of k minus 0. So that's this part. So corresponding digits. So here now we have let's see, we have I equals 0. D of 1 is greater than n of I. D of 1 is equal to n of I is all 0, and I plus 1, j minus 1. Okay, so here d2 is greater than n of j. So yeah, if d2 is greater than n of j, then it's also bad, so that's what we're doing here. So if we're going to actually take this out. So or d2 is greater than the corresponding digit of n of j, and whoops, or, so this should be an and d2 is greater than n of j. So if, okay, so this is or, and we got to check if d2 is equal to j or d2 is equal to j, and to corresponding digit of j, and it's all zeros. So and if it's all zeros from j plus 1 and then k minus 1. And d3 is greater than n of k. Okay, so that's also bad. So if d3 is greater than corresponding digit of k. So I is equal to 0. D1 is greater than corresponding digit I, or D1 is equal to corresponding digit of I, and it's all zeros of I plus 1, j minus 1. So between I plus 1 and j minus 1. So if it's all zeros, it's bad. So like if I have like 1003, like if I do 1003 and it has 2 zeros, it's bad. Between 1 to 3. That'll be bad. D2 is equal to corresponding digit of j. You know, I should actually write things down because I feel like you guys wouldn't understand what I'm saying. But, I mean, I'll see. So if D2, okay, so I'll explain this again. Hold up, later on. So D2, so D3, so D2 is equal to corresponding digit of j, and is all zeros from j plus 1 to k minus 1, and d3 is greater than the corresponding digit of k. Okay, so that's what we're doing here. K plus plus. If it's not equal, we're going to do k plus plus. And I think that's it. And then we'll just see out answer. So I'm going to submit it and see if it works. And then I'm going to explain it to you guys again. So, and then we'll see if we could do a we'll see if we could do a DP solution, dynamic program, what they wanted us to do. So this is actually like a hacky way to do it because we're brute forcing. And then after that, I'm going to attempt the third problem. Okay, I'm getting wrong answer. What's the problem? Let's see. What am I getting wrong answer to? D3, in function bool warning parentheses. Okay, so I'm getting a few wrong answers. What am I getting wrong at? And 1. There's a way to check the wrong answers, I think. Okay, let's check the first beginning wrong answer. Let's see. So we have 100. Let's run it. So let's see. Let's say we have 101. Okay, so it doesn't print anything. Huh. That's weird. 101. K is equal to 1. Oh, I didn't do. What am I doing? I didn't do that. Oh, still wrong answer. Okay, what is the problem? It's good. This is good. Good that we're debugging. It's good. It's good. It's good that we're debugging. Okay, still getting wrong answer. What is this? What am I doing wrong? Random 0, 1. How do I see the sample of what I'm failing? Let's go back to his code. Okay, I'm gonna go back to the code and check something real quick. What is this? Overflow and forecast for wider bit. This is just convert this into an integer. What's this problem? Okay, I don't know. I don't know. I don't know what this. Well, I don't know why it's complaining. Okay, it might be something to do with bad. Let's see. Let's go back to his code. See what he did. Bad of 3. Yeah, if it's not bad, then we're gonna do ijk. It's not bad. d1, d2, d3. Then d1, d2, d3. Then that's the corresponding issue. Let's see. Oh wait, this is my solution. What am I doing? Yeah, this is my solution. I to 3, I to dg. Okay, that's right. J is equal to j plus 1. K is equal to j plus 1. Yeah, that's right. Okay, that's right. Something's wrong with our bad. There's probably something wrong with our bad. Answer is equal to 0. Answer is 0. That's good. I think answer is 0. Length is n. Length is n, right? Size of n. Size of n. N is a number, so we'll do size of n. This should be right. Let's go back to bad. Okay, instead of doing corresponding digit, I'll just call it nk because this is really ni, nj, nk. Okay, if I is equal to 0, that's bad. And d of 1 is greater than n of I, it's bad. Or d of 1 is equal to n of and all 0. Okay, so and it's all 0. And it's all 0. Oh, we don't need this. We actually don't need this. So all 0 between here to there. I plus 1. So if d of I is greater than and d of I is equal to... Oh, wait, no. We do need it. What am I doing? Wait, we do need it. If it's equal, then we have to check if it's all 0 between. And if t2 is greater than e, yeah. So here. Oh, okay. So we need parentheses here. Hold up. Yeah, we need parentheses here and then here. What is this? Yeah. I think that should work now. Check, submit it, see if it works. I don't even know what the test cases are, so I mean, might as well try anything. What is the wrong answer? 2 of these are wrong. Random 2, random 3. What is random 2? How do I see the wrong test case? Must be a way to check the test case of what you're failing. Hold up. Must be something that was failing. Let's see. DJ. 1, 2. Bad and minus. That is bad. Let's see. Hold up. Let me just check this again. Hold up. Hold up. Hold up. There's parentheses here. Did we do parentheses up there? I think we did. Hold up. Get rid of these. Close it. Yeah, there's only 2 parentheses there. Let's convert this to NJ, NK. Let's see this. I is equal to 0. D of I is greater than N of K, and I and D. Or D of I and, oh, I don't need an and here. So if this one is and, first parentheses, we don't need this, we don't need this, we don't need this, this just clogs it up. Or D of 1 is equal to N of I. So this is for, and this. We need this. D of 2 is greater than N I, or D2 is equal to N of J. Is all 0, ij plus 1, k minus 1. Oh, yes. Let's see. 1, 2, 3, 4, 5. 5 parentheses. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, might have been a parentheses issue that caused it. Let's see. D2. Yeah. 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 Okay. Actually, let's go back. And it got A seed. Okay, that's good. Okay, it got A seed. Okay, guys, so let's explain what we're doing here again. Okay, let's wrap this video up again, see what we're doing here, and then I might actually go to bed now. So, let's see. So, yeah, okay, so let's go back to the problem. Let's go back to the task. So here, what are we doing? So here we're trying to find the number of digits between 1 and n that contains exactly k non-zero digits. Okay, so now I'm going to reiterate the whole problem again. Okay, so if k is equal to 1, what we could do is we could take out everything from the rightmost digit except the first one, right, are going to have non-zero digits of 9, right? Because for each of these to the right, you could have a 9 here, 9 digits here, because we're trying to find non-zero digits, right? Exactly, k non-zero digits. So the number of ways we could do this is have a 9 here, right? Like 9 different digits, 1, 2, 3, 4, 5, 6, 7, 8, 9 here, and then have another 9 here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9 here. And the first one, we know it can't be a 0, so we could just add whatever the digit of that is to our answer. So what we would have in the answer here would just be the size of the number of places we have minus 1 multiply by, so minus 1, which is minus 1 not including the first value, then that'll give us this, and then we'll just multiply it by 9 for each of those, right? And then we add it with the number of digits for the first place. So that's what we do here, that one. Okay, now for input 2, what we're doing is we're going to brute force from every single possible digit from this place to the right and from this place to the right. For j here to the right, j plus 1 to the right. What are we going to do? We're going to go pass in every single digit. 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the non-zero digits for this place, 2. And then 1, 2, 3, 4, 5, 6, 7, 8, 9 digits for 5. And what does that do? That means that we're going to check if each of these are bad, right? So if it's greater than the current digit, then we can't have, that means it's bad, right? So if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, if I have 4, right, I pass in 4 into here, and it's greater than 2, that's bad. Because why? Because we're trying to find the number of non-zero digits that contain 2, from k, right, from 1 to n. Our n is 25. There's no possible way that any digit starting from 4 and after is going to be in the range of 1 to 25. So that's not right. We can't do that. Let's say I pass in a value 6 into 5. 6 is greater than this digit 5. Since 6 is greater than the digit of 5, that means that it's bad. Why? Because no possible value 1, 2, 3, 4, 5, 6 is in the range from 1 to 25. Right? That's what we do here. And we do the same thing for 3 digits and 2 digits as well. We're just going to pass in 1, 2, 3, 4, 5, 6, 7, 8, 9. Pass that in. Check if it's bad or not. If it does equal to it, so let's say I have 2 here. Right, 2 here. So let's say I pass in number 20. Let's say I have digit 2 here. So I pass in 2 for I. That means the right, whatever's afterwards between here and to the right, cannot be 0. Right? From here to here, it can't be 0. Whatever's afterwards. The reason why is because if it's 0, then that means that our value, if it's equal to 0, that means it's bad. Because we're trying to find exactly k non-zero digits for the range of 1 to n. So if we're passing a value of 20, let's say 20, it's bad because it contains a 0. And how do we check if it contains a digit 0? what do we use is we use a prefix sum to add up all the values from 1 to n right here. And then we're going to use a prefix sum in a function called isAll0 that gets the sum between those two ranges from the left to the right. And if one of the if the ranges of the sum is equal to 0, then that means it's bad, right? It's all 0. So it's all 0 here. So that's why it's bad. So that's why we do that here. And we do the same thing for brute forcing for bad for I, J, and K. So yeah, that's this problem. I hope you guys enjoy this live stream. I think no one's in this chat at the moment of this live stream. But yeah, rate, comment, subscribe. I'll check you guys later. Peace.